Okay, we have some people from Aguascalientes, Mexico, middle of nowhere, Missouri. Good, Chihuahua, Mexico also. So thanks for joining. Okay, again, welcome everyone to this new episode of Improving Webinars, where our improvers share the knowledge. If during this presentation you have any question, you can ask via the Q&A feature, and I will pass them on to the speaker. And today, Alex Arzola, a Mexican software engineer with more than 15 years of experience in IT, started working with Microsoft Stack and then gradually traversed several technologies. Currently, a technical solution architect at our office in Improving Mexico. Without any further ado, I'll give the floor to you, Alex. Thank you.
Thank you. Thank you very much, Sergio. So before we get started, yes, if you have any questions, please feel to type them in or to tell them if you're here in the office. I will try to answer them as best as possible. And when we start now, the talk is about upgrading really old legacy systems and staying alive while doing it, because as technology has grown and moved forward at an incredible pace, companies still have legacy systems, which is perfectly normal. I mean, we're in a different internet than 15 years ago or 20 years ago. So the thing here is that companies still keep some of those systems running as the banking system. And we're going to talk about how to come up with an upgrading plan and not dying during that upgrade. So like Sergio said, I'm Alex Arzola. I'm a technical solutions architect here at Improving Mexico. I love playing table tennis, and I am a bass player. So this is not a matter of if, but a matter of when. So at some point in our careers, we have all been faced with one of the most feared titans in software engineering, which is dealing with a legacy system that has been there for a really long time, that's mostly supporting the whole company infrastructure. And we are tasked with upgrading this application, but there's a caveat. We can't disrupt business. So if anyone wants to say OMG, that's perfectly fine. This is Chronos, Greek Titan. He represents time. And legacy systems are built to stand time. Okay? So if you have any questions, let me know. Let's get started. So since this is a very daunting task, let's talk about why security must be factored in right when we start, when we need to assess the current systems and risks so that we can come up with a blueprint. And also we need to have the talk with the stakeholders, including the fearless C-suite people. Then we are to build a realistic upgrade plan. And then we're going to move on to closing the upgrade project and contemplating what's next. As a bonus, we will see a few real life cases or scenarios that, because people didn't bolt in security from the beginning, bad things happened. Any questions so far? So a quick disclaimer, while I was preparing for this talk, I bumped a lot into the term operational technology, and this is heavily related. However, we're going to focus on information technology. Operational technology, you refer over as to PLCs and like larger machines. But in this case, as I said, we're going to focus on IT, information technology, right? Let's get started. So being preemptive, this is why we need to start with security from the get-go. And this is why it's so important. It's easier to implement when we first start. Security should always, and I repeat, or stress it out, always it's a non-negotiable, especially during these days where we have so many cybersecurity hiccups going on here and there. If we wait, cost will skyrocket. If the longer we wait, the costlier it's going to be. And then most of the time, if not all the time, waiting until the very end to implement security in an application turns out to be a massive oops or a recipe for disaster. Hence the blue splat. Any comments so far?
Okay. None from the audience. Thank you.
Okay. So we're going to dive right now into this, and we're going to start talking about the blueprints of what we currently have, which is assessing what we currently have right now in our hands in terms of the applications. For the people here and out there, can anybody tell me at least what two of those icons represent? Hard disk database. What else? Okay, anybody in the Q&A in the chat? What's the remaining icon, the blue icon?
Someone saying router.
Exactly. That was a Cisco notation for a router. If you recognize those, if you're able to recognize those icons, it usually means that you've been around long enough to know what a legacy system is. So when we're talking about newer from scratch applications, it's all happy-go-lucky. But what happens when we talk about older systems that have been running for 10 years, 15 years, or even longer? This is a spot where the non-functional requirements come into play really nice. And we're talking about the famous airlities. Don't quote me. You can quote me on that because I followed a solutions architecture webinar, or talk that was awesome. So things like availability, how like the application needs to run at all times with the SLAs and what have you. How scalable it is right now. It could be stored in one of the servers, like on-premise and in a physical server, which has limited resources. How can we scale it? How reliable is it? Do we have redundancy? Do we have a very strong and robust network? Do we have more than one server that we can have a master and slave or some replication? How maintainable is it? Is it easy to just go ahead and make a new feature? Is it okay if we decommission a part of the system? And what is going to be taken down? Is it compatible with new technology? Is it compatible with like containers and Kubernetes or Docker images? Is it compatible with the cloud? Because we face those things currently. How performant is it? We might have a super awesome server back then, but now it's barely keeping up to par with what the current customer and the technology demands are. And the most important, how secure is it? Who can access it? How easy it is to target it as part of a cybersecurity attack? How resilient can be? And things like auditability, like who can run audits and check the statistics and what have you. This is what will give us the blueprint of the applications and like the lay of the ground of what we currently have. And this is the key so that we can come up with a plan and that we can start building new things on top of this or a brand new application. However, the one thing that I will stress again and again is that in spite of taking or besides factoring in all of these things, security is the key. And I am pointing it here. This is the key, right? Questions so far?
No, none from the audience.
Three. Right. No question. Okay. So how can we get a better grasp on what's going on? So these are just a few examples of questions. The list can be endless, but these are some of what I consider, from my point of view, some of the most important ones. How old is the system? How long has it been standing or sitting there? 1 year, 5 years, 10 years, 15 years. That really matters. Does it interact with other pieces of technology, or is it like a standalone piece, like a monolith, if you want? Is there still someone from the original development team around that we can ask questions? Because happens more than often than we get thrown into projects and, oh, guess what? There's nobody from the original team. And the older people who are there, they're not even from the original staff who developed it, but they've managed to get the grasp of the application as time went by. But still, like the OG knowledge can be lost. Is there any available system documentation? Yet another key question, because again, more often than usual, we get like sent to projects, and as consultants, it's usually our job to figure how things work. However, having documentation makes things so much easier and so much smoother to run. But if there's no documentation, this is where the business analyst and the systems analyst come into place. And if we don't have those roles, us, the software engineers, are tasked with doing that. And that is a very challenging part of the project. And then what is the worst case scenario if the application goes down? And as a series of sub questions would be like, how many people would be affected? Are there any other satellite systems that can be affected? How much, give or take, would it cost on a like per minute basis to the company to have the system down? I mean, these are hard questions that we must ask in order for us to come up with a better plan, because even these questions of the worst case scenario, if we don't pose them, we risk going on the very optimistic and happy plan. And then if anything goes south, we're basically screwed because we didn't measure those risks and we didn't take them into account. So by not doing that, this could cause a company or companies from starting from hundreds to thousands to tens of thousands or millions in whatever currency they use, or we can bring them down to their knees. And that is such a not good scenario.
We have a
This,
question from the audience, if you don't mind. The question is it standard best practice not to allow new functionality when upgrading an application to the cloud?
no, actually, that's a very good question. And that's part of the things that I'm going to mention it right now because I sort of forgot to put it in. So it's when doing upgrades, there are two tasks. One is keeping the current system alive. However, this system can still be having new features on top of it, getting added on top of it. And then you have the new upgraded system that eventually is supposed to replace this one. One of the bigger challenges here is that while features are getting added here, we need to map them out in the new applications. So it's like not it's very weird if you order like a code freeze and say like no new features until we finish the upgrade, because that would in turn that would disrupt business. Because if you need to add a new feature that's crucial to your business or mission critical, you need to do it in your legacy system and in the new application. If not, there goes some money out the window. I hope I answered the question. I'll take that as a yes. Any more questions, Sergio?
No, you can move on.
All right. So now that we have the blueprint, we need to have the talk with all of the stakeholders, which can be kind of scary because this includes the C-suite people, and we will see why. So the stakeholders are all the parts, let it be people or systems that talk to our applications that we will be upgrading. I mean, we can talk to the applications, but we can get a feel of how they work. However, we have several types of stakeholders. We have engineers, we have project managers, we have users, we have UX, UI people, we have QA folks, we have the C-suite as in CEO, CIO, CMO, C whatever, O, right? So those kinds of stakeholders, be one or a team, speak different languages that we cannot have the same talk for like a one size fits all talk. If we are going to talk to the engineers or the development engineers, we need to basically talk in ones and zeros, as in like the feature, what's it going to do, architecture, code, how is it going to be arranged, and what have you. Project managers care about dates and risks in how are we going to get this project to a good closure. Then the users, what is this going to do for me? Is it going to save time? Is it going to automate things? Is it going to make things easier, even if it takes the same amount of time, and what have you? And then we have the design for the UI and UX people. Like, how is it going to look? I need it to look cool, but it also needs to be functional. And if there are any UX, UI people here, they know what I'm talking about, because it's usually, we have to match what's in the screen with the code. And that can be challenging some of the times because it's two different mindsets. And we have to sort of overlap them in a very good way, because very nice things can come up when engineers and UI people come play nice. And then we have the C-suite, like I said, CIO, CMO, COO, CEO, and what have you. This time we cannot go to the nitty-gritty of things. This time we have to talk about cost. How much is it going to cost to build a new application? Is it going to save time? How much time? We need to give them like very high overviews of the application, because what they're interested in, because they're usually very busy people, is to know if it's feasible, how long would it take, and how much is it going to cost, and if it's going to bring anything down, if it's going to slow things down, or any other potential side effects that might come up at a very high level. Data estimations, how long will it take? Will the whole upgrade take? And the difference between here and the project manager is that the C-suite cares about like the whole project, as opposed to the project manager that care like about, and if we were in agile methodology, we care about sprints and how many weeks is this going to take, as opposed to like, hey, it's going to take us about 6 months. And they're like, okay, you say 6 months. If you commit to it, you make the most out of the time, you split the dates and just make this happen. And then what are the larger risks bringing on the application? What happens if we disrupt connectivity with other parts? What happens if there's a blackout? How can we be more resilient and what have you? So any questions about this? Because this was a very short section. Audience?
Nope, nope. We have no questions from the audience.
All right. One of the things is basically, since we're talking different sub-languages, we need to be very tactful and very concise when talking to the people. And be aware that some people might have a technical background that might not have been used in a long time, or they might have a technical background and we need to be very concise with them. And one key thing here is to be like super reassuring that we are going to make our best effort or put our best effort into making things as smooth as possible for the upgrade itself. We need to be mindful of the upgrade plan. And also we need to have a rollback or a disaster recovery plan in case things go sour to a point of no recovery. We need to factor that in. The more reassuring we are, the smoother the talk will be, and the better the plan will be. All right. We'll be moving on now into the next part, which is building a realistic plan, an upgrade plan. Notice the happy planner there. And okay, it is legible. So there are one of the terms I bumped into was the Big Bang approach, which is, I think, most of us have seen it and we've tried to implement it. And usually this is an accident waiting to happen. The Big Bang approach is like, let's do everything at the same time, and it doesn't work. So there's, for example, the term that Martin Fowler came up with, which is the strangler fig, and I'll talk a little bit more. So how can we write the plan? We need to be aware and comfortable with the knowledge we have of the application so that we can start writing a per module timetable, like the login, the user profile. I don't know if we're talking about like a manufacturing company, how does the raw materials go into the storage room and what have you. Once we have a time per module timetable, then we can lump it up and then we can see like the larger picture, or the bigger picture. After the timetable, then we need to, or we should come up with in-depth schematics around what the components are going to be. So for example, going to the more nitty-gritty would be like class sequence and activity diagrams, quoting the UML here. What is the current and the new network layout? Do we have any containers in any of the other any application? What does the security look like? And this is where we can find out if there's any security or if there's none. And this is where we can jump in to write the security modules so that we can prevent any oops that might happen with the current application in the newer. And this should also teach us that security is very important for the legacy application and needs to be put in as well. As I mentioned before, the strangler fig pattern which was coined by Martin Fowler. It's basically we start writing code. Let's say we have the login feature. So we have the old school way of doing it, and then we start writing a new login module around the current one, and then we gradually start decommissioning that module. Any questions with this one?
So when you say big part of this, you have to wait the final code or the final feature is released. So we have to keep asking of the feature to the stakeholders.
Truri here is asking, or Jesus is asking about the Big Bang approach, if it means waiting until the very end of the feature to be developed. And no, a Big Bang approach is trying to replace the whole application in one pass and hoping for the best, which it's not going to happen. It's not about the methodology. I mean, you can use either a methodology, but it's just trying to, for example, let's say you have a very a very, very large application with 100 modules. And you say, okay, we're just going to scratch or scrape the whole application and build a new one from scratch at the same time. You can use Kanban, you can use Waterfall, you can use Scrum. Still not going to happen because it's so large. It's just very, very large. Did I answer your question? All right. Questions from the audience?
Nope.
Right. And then after the Strangler fig has been put in place, we can start decommissioning the older modules as long as there are no features that need to be built in. And this plan also allows us to leverage our current stacks of technologies that we might have in our environments. For example, some companies might have an AWS cloud, some might have a GCP cloud, some folks might have Azure, some might have their own cloud for whatever reason. Some might have their own on-premise infrastructure, which works, and they want to leverage it, which is perfectly valid. And this involves using the containers, the networks, what source code tools we have, source code control tools we have, what like any other security features that we might have, which I will talk in depth a little bit more later. So those are the things that we need to leverage as like if we have Kubernetes available, how many pods, or how are we deploying the images and what have you. All right, moving on, because then we have to go into the Q&A section. Okay, we've come up with a timetable. People have said yes. The two applications are starting to work in sync. We're going to close the project. What's next? As we approach the end of the upgrade, what does the future have in store for us? Well, there are a few lessons that we need to learn from successfully upgrading the project. I mean, in one of the projects I've worked on, the approach was to first get the lay of the ground, ask questions around, and then some of the stakeholders might have gotten a little bit antsy and they were like, hey, what's next? So we said, yes, we are going to do upgrade. This is the plan that we have. Please let us know if there's any questions. So we learned that during that upgrade. And the key thing, or a very important thing, is that upgrading the application should be a little bit more about the journey rather than the goal, because we all know the goal, which is having an upgraded application, working upgraded application. But if we focus just on the goal, then we skip the journey part, which is learning, gathering requirements, implementing features, back on the learning new things, how to do things, probably optimizing the old applications with some of the newer pieces of code that we've learned about. Another thing is learning that security is a key during this journey. We cannot skimp out of it. We cannot be stingy about it. This has to be put right from the get-go. That's a non-negotiable. Gather lessons learned from the project. Excuse me. Then the legacy system will stay up and running until the very last minute that it's needed. Why? Because that will disrupt business and that would cost the company some money, or a lot of money for that matter. Constant knowledge sharing is another important fact that we need to be mindful of, that we need to pretty much be in constant sharing of what we learn with what other people learned, because it's a team effort. And if it were a one-man project, still sharing what you learn, can't stress enough how important this is, because by sharing the knowledge, you also let what you learn sink in a little bit, or much more. And it gives you a much better grasp of how things work and how things should work and how things will be working. And another important thing is to celebrate when the project is done. This is a very important thing to do, because it's like, I don't know, Friday, five in the afternoon, you submit your last change, the system goes live over the weekend, and it's another day in the calendar when it took you, I don't know, a year, 2 years to upgrade the application, which was massive. I mean, it's important to give ourselves some pats in the back and to celebrate the achievement that it is to be able to upgrade the application. Do we have any questions so far? Jesus? Audience?
No questions for now.
All right. And then this is the bonus part. What happens when we wait till the end to put the security into applications? And I have some real life examples. I omitted the company names and the office names because this is a public talk. So we waited too long to implement security, and this led into an ongoing massive oops list. In 1996, a US government website gets hacked. In 1997, AOL, a really old ISP, well, this one I skipped, gets hacked and people started using it for free. Then in 1999, the US Embassy got hacked. with racist and anti-government slurs and slogans. Then in 2000, the I Love You work infects worms, sorry, infects mainframe systems. In 2001, a prominent software company gets its DNS servers hacked. 2011, important U.S. bank gets hacked. Credit card numbers are leaked. 2018, computer systems in Connecticut get seized by ransomware. 2020, a world famous online game gets hacked. And the list goes on, sorry. And this is a moment where I am extending an invitation for people on the audience, both physical and online, to share some examples of these oops that either you've faced personally or that you've seen in your careers. Let's give that about 2 to 3 minutes.
Okay, while we wait for people to maybe think about their experiences, we have one question from Miguel Angel. The question goes, could you point out some differences or challenges between upgrade and operational system, upgrade and information system?
Sure. Operational systems or operational technology usually refers to started with the term older. It means it's linked to machines. For example, CNC machines, cauldrons or furnaces and stuff like that, HVACs in larger buildings. That's like the operational technology. And a good example of like HVACs are like the ones in the buildings. And then how we have how we control them with the remotes, and then how we connect them with, for example, let's say we start we start managing the HVAC system through the company Wi-Fi, and how to avoid an oops, put it in a separate network, like super isolated network. Did I answer the question, Miguel? Yes.
Okay, you can ask a follow-up question if you need additional information.
All right. Any more questions while people come up with examples?
Not for now.
All right. Do we have any examples of the oops?
We have one comment from Bruce. Someone hacked an unknown entity. As a result, someone used device to make physical credit card with my info and swipe it at an out-of-the-state gas station. Luckily, credit card company contacted me and by default froze it, as my history of charges was never in that state.
Wow. Speaking of operational technology, any examples, Jesus?
CrowdStrike,
CrowdStrike?
Windows Station.
Yeah, Jesus here has a very good example that's not related to a hack itself, but I mean, what was it, last year? Last year with the CrowdStrike upgrade that froze pretty much the whole world because the Windows patch wasn't fully tested. That's disrupting current systems or business. Any other examples we might have or read about? Okay.
No, you can go ahead.
All right. So how do we okay, we've been hacked, there's ransomware, what to do? So in order to mitigate those oops to the point where they almost don't exist, hopefully, we should be doing a few of these things. There are many more things. If people can come up with more examples, more than happy to listen to them. Both the security in your legacy systems as soon as possible, if possible. Segment your network properly. Train your personnel. Social engineering, because that is one of the most used ways to gain access to older systems. And then have disaster recovery plans. Make backups as often as possible. Implement ACLs, access control lists. Implement physical security, fob keys, ID tags, logs, cameras, whatever, so that we know who does what at all times. Document your findings. This is documentation. I know a lot of people don't like it, but it's always what during the postmortems and during like the actual oops or the actual hacks, having documentation really can help us turn things around. So these are just a few examples. There are many more. For example, I think in the near future, someone's gonna mention something about having a real old application that was isolated into its own VM, its own virtual machine, so that just the people who need it have access to it. All right. And then once this is done, congratulations. The Titan has been conquered. And this is the time for any questions that people might have about either older or new technology.
We have a couple comments on the chat and a question. So Bruce also saying something like even something innocent as an ambulance service who took a family member to a hospital got hacked and data breached. Notice that they're coming more frequently in mail about data breaches. Seems to be a sad norm lately.
Yes. Actually, that reminds me, a few years ago, I read about a guy who was able to reverse engineer hospital machinery, and he was able to tap into pacemakers and what have you, and he could have zapped people's hearts if he wanted to. So, like, those are the things that's why security is so important. Go ahead.
Uh, Talking about health, Melissa is saying that she can't remember the name, but the extortion in healthcare companies that recently happened.
Hmm. Thank you, Melissa. Wow.
And
Anybody else?
she was also looking for clarification on the term vault.
That's very relative. It can be very relative, I know. But in this case, when we talk about legacy systems, we're talking about, I would probably give it a 5+ years old time window. I think 5 can be considered legacy because technology moves so fast that what's good, like what's new today, can be outdated tomorrow or 2 days from today.
She's asking about vault security in the slide.
Bolting security. Let me go
Hmm
back where it says bolting security in your legacy systems.
hmm
It means that you need to secure your systems as soon as possible. Bolting is like, unfortunately, the icon doesn't represent what the actual bolt meant. It means like a screw, but it means to secure the system as soon as possible with the measures I'm mentioning here, or adding a security layer if you have like a multi-layer application, just making sure that the cyber threats are as far away as possible, and also the physical threats. Very good, Melissa?
Yep. There's a question from Noah. I know many insurance company, banks, governments, etc., all rely on super old code, often from before 2000s, sometimes
Mm-hmm.
written in COBOL. What are
Mm-hmm.
your thoughts on this? Why do you think they do it?
That was a technology that was available back then, and it turned out to be the latest and greatest. I mean, even back then there were cybersecurity threats. The thoughts are that those things are so massive. I mean, just ask the banking system. Those things are so massive that until recently, people started attempting to upgrade them, and not many have been successful. I mean, it's not about the language they chose because they chose Java. It's about the just how massive the banking system is. And it does sort of come to a point where like if it works, just let it be. But still the time will come when those servers will stop working and you can migrate the data so many times before you hit a wall. So the upgrade is somewhat inevitable. However, not even like the newer tools are like code generators and what have you are able to do like an actual successful migration. People have written tools, they've sort of migrated pieces of code, but it's so large that it's very, very difficult to successfully do like a full upgrade. And since they're so, I mean, archaic, and because I mean, some of them have been around since the 80s or 90s or even earlier than that. There's no longer so many people that know, for example, COBOL. And then the tools, since they rely on computers and computing, they have limited resources. So those are my thoughts. And if it's possible, I think it is. It will just take a really long amount of time, and sometimes and it will take a lot of people to do it. I think we have a question here in the office. Go ahead, Jesus.
Okay, so from your experience,
Uh-huh.
which is the hardest to migrate or operate as a system? And how do you develop that?
Jesus is asking, like, based on my experience, what was the hardest thing to do during an upgrade? And probably it wasn't the upgrade itself, but rather than talking to the people involved in the upgrade, that was the hardest because we needed the people to buy our idea, to buy the pitch that we threw at them. When it came down to the code in one of the projects it was like a 15-year-old piece of code or a set of pieces that were 15 years old. The hardest part was understanding how they're all intertwined and how they're all connected. That was one of the hardest things because the code, if you know the language and you know the basics, you can do it. However, understanding the logic and how the information flows from one application to another, that's what makes it really, really tricky. Okay. Audience, any more?
No,
Any other,
no questions.
any examples of hacks? Banking, healthcare, insurance? Going forward. Well, I guess this is it then.
Awesome. Thank you so much for the presentation, Alex. This was amazing, really full of information. Makes you wonder about the security of the applications you're working on. Thank you so much for sharing all your experience with us. Okay, good. And for the audience, remember that next week, September 10th, our colleague Mauricio Jimenez will be presenting the Exceed util deception and attack on open software you're probably using. And we're going to share the link so you can check out the information and register right today. Again, thanks everyone for joining today. I hope you enjoyed the presentation and see you next time. Thank you.